Hello and welcome to Learn Redis with Python and Django. I'm Xander and I'll be your guide throughout this course. Now this tutorial is part of a full course playlist available for free on YouTube. For a deeper, more structured learning experience, the complete course is also available on Udemy. You'll find all the links and resources in the video description. Now don't forget to subscribe to the channel for weekly promotions, exclusive discounts and Udemy course giveaways. In this tutorial, we'll take a look at how to work with string values in Redis using append and the string length commands. So these simple tools help us manage and measure string data efficiently. Now this topic is important because it will help us interact with and manipulate string data in Redis confidently. In Redis, strings are the most basic type of value we can work with. They hold anything from simple text to more complex binary data. What makes strings different from other Redis types, like lists, sets, or hashes, is that a string holds just a single sequence of bytes. No structure, no nesting. Now that doesn't make Redis strings any less powerful. Strings can grow up to 512 megabytes if needed. So far we have learned how to perform common operations such as setting and getting string data. Now let's take a look at appending and measuring string data. Right, so let's take a look at the append command. Right, so let's go ahead and set welcome, the key welcome, with the string hello. Okay, so to append that, we use the append command. So this command takes the current value of welcome and appends the string, in this case to welcome. So Redis handles this efficiently, simply joining the strings together and updating the stored value. So when we make the update, we go ahead and use get to return the value. We can now see the string holds hello world. So this result shows how Redis allows incremental string construction without replacing the entire value, which can be useful for logging, status messages, or progressive data updates. In the case that no set command is used before append, if, for example, we append user bio I love chips, which doesn't exist, Redis will create it and assign it the value, in this case I love chips. So if the key already exists, append will simply add the string to the end of the current value. So append is flexible. It can both initialize and extend strings. Now this might be useful in some scenarios. There's no need, for example, to check if a key exists before appending it, which makes it a convenient and concise operation in many scenarios. Let's now take a look at how to measure string lengths in Redis using the string length command. So this is simple but useful command for checking how much data is stored under a given key. So let's go ahead and store a new key. Redis is fast, and then we can use the string length and then the key to then return the string length, in this case 13. Now it's important to understand what this number means. Redis counts the number of bytes in a string, not characters in a sentence or words. So spaces, punctuation, and every single character is counted one by one. So in our case, Redis is fast, contains 13 characters, including the spaces. Now let's remember, for simple strings like we have here, standard ASCII characters like letters, numbers, and punctuation, each character is exactly 1 byte. So the count matches the number of visible characters. In our example again, Redis is fast, it's 13 characters long, including the spaces. Therefore, Redis returns 13 because each of those characters includes spaces, uses 1 byte. So let's just see this in action. Here we set the emoji smiling face. We'll go ahead and run and save that, and then we'll go ahead and take a look at the length of this emoji, which I think should be around about 4 bytes. Nope, sorry, it's 6 bytes. So that emoji is 6 bytes. So you will also find that, for example, non-English characters may also have longer lengths. So, for example, something like this, if we were to take a look at the length, that's going to be around 10 bytes. So what we're looking at here are Cyrillic characters. Each Cyrillic character or letter takes 2 bytes in UTF-8. So these examples show that while Redis always counts bytes, not characters, understanding and encoding helps you interpret the results accurately, especially when dealing with multi-byte characters. Right, so let's finish up with handling non-existent keys. What we've learned so far is that when we use append on the key that doesn't exist, Redis doesn't throw an error. Instead, it creates the key and assigns the string you're appending as its initial value. So this key doesn't exist. We go ahead and run, and we create the value in key. Now remember, this is a very similar behavior to set, but with the advantage that you don't need to check whether the key already exists. So append works both ways. It updates if the key is present or creates if it isn't. Now calling string length on a key that doesn't exist is safe. Redis simply returns a 0 rather than an error. That simply means there's no value stored under that key yet. I think that pretty much wraps up Redis string operations using append and string length. So in this tutorial, we saw how to add data to existing keys, how to measure the length of a stored string, and how Redis handles operations on keys that don't yet exist. Now each command was simple to use and consistent in its behavior, which makes them great tools for working with string data. Now, as we continue exploring Redis, remember that these basic operations form the building blocks for more complex patterns. Being comfortable with them gives us a solid starting point.